In the picture on the right we have our collision event. Let's assume we have already determined the curvature radius of the track of the pion, represented by the blue circle. Now, starting from the curvature radius, we want to evaluate the momentum of the pion. From the theoretical section you can find on the site POLI Lab at home, in the post dedicated to this activity, we know that the relation between the momentum p of a particle and the curvature radius of its track is the following one. P is equal to the charge q of the particle times the curvature radius times the magnetic field B. Of course, this relation holds in the specific experimental situation in which we are working. We are assuming that the magnetic field is uniform and perpendicular to the plane of the picture. Furthermore, we are assuming that the energy losses of the pion, and thus the velocity losses due to ionization, are negligible. Let's evaluate the momentum of the pion. The charge q of the pion is well known. It has the same charge of the electron, that is 1.6 in 10 to the minus 19 coulomb. The curvature radius was measured with the previous activity, and the magnetic field intensity is written in red in the application at the top right corner. B is equal to 0.690 Tesla. Just to show how to evaluate the momentum P, I choose a value for the curvature radius R. I assume a curvature radius equal to 0.9 meters. Putting these values in the equation, we get that the momentum of the incoming pion is equal to 0.994 in 10 to the minus 19 kilograms times meter per second. Let me point out these units may also be expressed as joule, energy units, divided by meters per second, velocity units. To become convinced of this, we have to remember the relation between the kinetic energy and the momentum P. The kinetic energy is proportional to a mass times v squared, while the momentum is a mass times v. To move from the kinetic energy to the momentum, we have to divide by a velocity. And that's why we can express momentum units as an energy divided by a velocity, joule divided by meters per second. In the next video, we will learn how to convert these units in those commonly adopted in particle physics: electron volts, an energy unit divided by c, the speed of light.